record here.
You're recording.
I am recording. Excellent. Okay. I'll figure out how to upload the recording afterwards. Okay, welcome to the regularly scheduled THP Cabal meeting. This actually kicked off shortly after the LSFMM that we had in Puerto Rico in 2019. A number of companies have got together and decided we're all interested in using huge pages for one reason or another. Let's see what we can do to help each other out. So we've been talking and working. We have these meetings every couple of weeks, but we've got to the point where I decided that we needed to bring in some more people, because I'm now proposing a much bigger project than we originally anticipated, and this is going to affect a lot of people. So it was time to bring in more people than just the people who now all agree with each other, so we can get some good criticism. So the way we were originally approaching this is to expand the concept of transparent huge pages. So instead of saying a transparent huge page is either the size of a PMD, i.e. 2 megabytes on an x86 system, they are now going to be arbitrarily sized. They're actually capped at 2 megabytes because I didn't want to test that layer of code, and that wasn't important to what we were doing. That's a restriction that could be removed later. But the concept was that a transparent huge page could all of a sudden be an arbitrary size. And we set off down this path, for 18 months, I suppose. And I kept telling myself, it's okay how much more complicated this is making things, because it's all gated by config transparent huge page. And so anyone who doesn't want this extra complexity can just turn it off. And that's how we argue for a lot of new features that introduce additional complexity, additional overhead. And I came to the realization a few weeks back that I've kind of been lying to myself about that. Almost everybody runs a distro kernel. Almost every distro kernel enables transparent huge page, because why wouldn't you? And so everyone's paying the price, basically. I'm paying the price of my laptop. I want to be sure that I get something for it. Right? So I started to actually quantify the cost of it. And I came to the same realization that Hugh did back in 2015, when he and Kirill were arguing about using compound pages versus using what Hugh calls a page team. And that is that every single time we manipulate something in a struct page, we call compound head. So if you lock a page, you call compound head. If you unlock a page, you call compound head. You increment the ref count, you call compound head. It's quite a lot of extra code. I'm measuring about 30 bytes of kernel text per call to something like put page, and that's a lot. And I haven't done any measurements on this, but I'm fairly sure that there's a CPU stall in there that we're introducing bubbles into the pipeline, where it has to wait for memory load to complete before it will allow the actual operation to go ahead. And worst is that the compiler can't actually see through a lot of this. So if you have multiple manipulations of a struct page, so you increment its ref count, you lock it, you unlock it, you decrement its ref count, that actually turns into really does turn into 4 calls to compound page in the assembler. And there's a bunch of reasons for that, but some of this stuff is marked as volatile. So the compiler doesn't know whether you've modified the compound head. It just sees that there's been a bit of assembly in there that has modified memory. So it's I can't know that it hasn't modified compound head. And of course, we do have things that modify compound head. Like if it sees a function call to if it sees a function call, it has to assume that function might have been split page, which definitely would have changed what compound head would do. So it can't cache the value.
But we can't split the page while we're holding a reference, and most of the calls to these things we do have to hold a reference to, although there are probably one or two places like compaction.
Oh yeah, so you and I can know that, Hugh. A human being can see that. The compiler can't know that.
Yes, I wonder if there might be some sort of annotation that we can give the compiler to tell it compound page is stable, and only in the dangerous cases could we say.
I think you can use something like attribute const on a function call, and it relaxes some of these things that Matt was just talking about.
Yeah, you can. I've also looked at trying to mark the function as being compound head as being idempotent. So if you call compound head of X, it can relax that into a single compound head of X, because we have a number of places where we find the compound head and then we call lock page on it, and the lock page just calls compound head on it again, because it doesn't know that the result of a compound head is necessarily a head.
What was it you used to tell the compiler about that?
I think there's a compiler attribute called idempotent.
Idempotent.
Yeah, if there isn't, then I was going to start asking GCC people to add it. Yeah, it's because GCC has function attributes like pure and so on that tells it various things about the function. It all seems very, very hard, and that's sort of a local optimization you can do. Whereas what I think we really want is a global optimization, because almost all the places where we actually manipulate a page, we're not manipulating a tail page. There are a bunch of places we do, but most of the time we aren't manipulating a tail page. And so that essentially is what a folio is. A folio is a struct page which is not a tail page. And so by using the incredibly weak C type system, the compiler at least can tell us, the compiler can warn if you're passing a folio pointer to a page, or more usefully, if you're passing a random struct page to something that's expecting a folio. And so that then lets us document, okay, this function is expecting to only get either head or order 0 pages. It can't cope with receiving a tail page. And that lets us make it very explicit that we're definitely not dealing with a tail page anywhere. The downside, of course, is that this is going to be a patch on the order of 100,000 lines. Right? I mean, everywhere that uses a struct page may need to be changed. The good thing is that there's no need to do it all at once. The patch series I have illustrates fairly well how we can slowly transition from using struct page everywhere to using struct folio everywhere.
I thought it would provide a lot of clarity for the work that, I'm sorry, I'm going to mispronounce your name, Zhao was doing with the get user pages.
Actually, Zhao is on the call. Zhao, do you want to unmute yourself? And
yeah, I suppose it could also simplify the fact that this VMAP trick would increase the amount of pages reused, because the head and tail pages wouldn't sit. You just need to care about the heads. It also improved that, which is one current flaw of the UTLB VMAP reuse and the zone device one. So I would like it a lot to have this abstraction, but I'm sort of new to MM, so I can tell the history of.
But I think I'd make the larger optimization, the larger observation that the optimization that Zhao was working on has been hidden in there in plain sight for
Oh, right.
how many years, because nobody really put together 2 and 2 that, oh, this is always a compound head and it's always the same compound head. But we're doing the same thing over and over again 500 times.
Yeah.
Yep. Yeah. So the one thing I did want to say is that while this is going to be a huge patch set, there's actually an advantage at every stage. Like every function which is converted to use folios instead of a random struct page will benefit to the tune of, as I said, 30 bytes of assembly per call site. And I think that's going to make it fairly compelling for people to go off and convert their own code. I mean, if I told you you could shrink filemap.c by 1 kilobyte tomorrow, you would say yes, please. And I think this is going to apply to a lot of device drivers. Even I mean, a lot of device drivers do manipulate a struct page, and maybe they should or maybe they shouldn't. But the fact is, a lot of them do, and so if they know that they are only dealing with order 0 pages or they're only dealing with head pages, then they can just be converted to use folios tomorrow. The tricky bit is going to be providing all the infrastructure. Right now, I haven't addressed changing the page allocators, because obviously the page allocators only return head pages. So they can all be converted to return folio with a simple cast. It's just a question of putting all the right bits and pieces in place to make sure that we have a lot of page allocator functions. And I'm trying to avoid writing I'm trying to write as little new code as possible. But I appreciate some of that is going to be.
Matthew, could you clarify what like where ages of folio begins and ends? I mean, when we convert struct pages to folio and like things like that.
Yeah. Okay. Are you asking how does that look today, or how does it look in the glorious future once everything's being converted that can be?
So I can see few places where we can get struct pages now, like from page tables, from page cache, from LRUs, from, I don't know, physical mapping.
Okay, so let me take those first 3 in turn. You said page tables, page cache, and LRUs. Okay, so for the page table, that's just going to return a struct page, because you can put tail page. Indeed, you have to put tail pages into the page tables in order for the CPU to be accessing the right memory. So if you are getting a struct page from a page table, you may get a struct page. You may get a tail page, and depending on what you then want to do with that page, you may wish to call page folio on it in order to get the folio that you then want to manipulate. For the page cache, what I found as while I've been working on the transparent huge pages patches is that almost all file systems actually want to get the head page, or now the folio. So a number of the patches that I've been submitting actually convert a number of the page cache interfaces to return head pages only. Those got a little stalled due to the bugs that he was good enough to find for me. This merge window, but I think there are going to be a lot. I think the page cache is in general going to return folios, and there will still be specialized interfaces to return struct pages for the few places that actually need a struct page. The third place you said was LRUs, and I believe quite strongly that only folios end up on LRUs. you don't put tail pages on an LRU. That doesn't make sense, because the point of having a compound page in the page cache, or a compound page anywhere in the system, is that you're going to treat it as a single unit, that you want to age this 32K at the same. You've allocated 32 kilobytes, you want to treat it all as one thing for the purpose of, is it dirty? Should it be written back? How old is it? Is it part of the working set or not? And we certainly don't today keep sub pages on LRUs. We just keep the folio, now the folio, on the LRU. And so yeah, there's no, if you somehow you could find out that it was not advantageous to treat a particular 32 kilobyte blob as being, you know, one page, I don't think we have a mechanism for finding out whether it's advantageous or not. You would want to split that up, and then you would have, you know, new folios, but you put them back onto the LRU list.
Do you imagine that there'd be a representation of a folio and its tail pages together? Or would it always, if you wanted that kind of representation, you'd always move to struct pages?
Yeah, so, and this kind of comes back to exactly how you define the struct folio. And John Hubbard, who I noticed is on, had an important comment when I posted this, saying, you know, I called it pages instead of page, and I'd made it an indefinitely sized array to illustrate that it was in fact an array of pages. And John said, you know, that reads funny. That usually we use the term pages to refer to a struct page star star instead of being actually struct page star. And I thought he was right. So I just changed the definition of struct folio to be to have a single struct page. And so if you want the subpage from it, I had in the original trial balloon I sent out, but I haven't put it in the patch set. I had a folio underscore page function, which would return the page at a given file offset. So you'd pass in the index, and it would return the appropriate subpage of this folio that represents that index. And there's a number of ways to do that. That because I'm dealing with file systems a lot, that was the natural way to do it for me. But this is one of those things we need to discuss, because there's a number of different ways we could do that. I mean, we could pass in, you know, I want page n from this folio, and then it just checks that n is within, you know, the 0 to 2 to the x minus 1 range, and then returns that page.
Well, is it even any? Go ahead.
Okay, as a question about like lifetime of the folio. So whoever converts struct page to folio has to be responsible for like guarantees that the folio cannot be split under you or like collapse into higher order page under you. Like whoever converts should take reference or hold like PTL for instance to prevent this from happening.
So that's the cunning bit. Folio page, page folio is simply, it's exactly the same set of bytes as compound head. It just comes back with a different type.
Yes, I mean just from type safety for folio to mean anything, it has to guarantee that it cannot get from order 9 to order 0 under you.
Right. So
whoever, yeah.
That's going to have the exact same set of guarantees that we have today, right? That you have to hold a ref count on it in order to prevent it from being split.
Yeah, I was just going to ask, isn't this exactly the same as what we have with the compound head? And you just answered it. So I don't think we are forced to go through all the stuff that we had to go through for compound heads.
That's true, but currently struct page itself doesn't mean that it's what order it is. So it's not comes from type itself.
Well, but if you call
so there is-
compound head on a struct page, you have to be careful that you're not doing so with a race to change compound head. Otherwise, it's just garbage anyway, I think is what we're talking about here. So presumably all the existing compound head users are doing it right.
Of course they are.
Absolutely.
And but I like the kind of clarification that to get a folio, maybe you're right. To get a folio, it's not just open coding compound head. Maybe it's something like, you know, in the page table walker, we have the try grab compound page that could be converted to a folio that gets the reference count. That does it all safely. I don't know if there's other analogs in the page cache. It kind of sounds like the page cache is returning folios. So the ref counting is maybe more natural.
So the page cache has actually been through several iterations of how it handles compound pages. What Kirill originally did was treat it very much like the page tables, in that subsequent indexes each got a tail page, and so when you looked at the page cache and you had to pulled a tail page out, you had to go back to the compound head, update that, check that everything was still okay back there. I changed that about a year ago so that we only store we install head pages, and so now you load the page, you do the ref count dance that's done for any page, and then you say, oh, the index of this page, this is a head page. I need to go off and find the exact sub page that I was looking for. And it turns out that's actually a bad idea because most of the callers actually do want the head. The callers who have compound pages actually want to get the head page most of the time. So it was all wasted work.
Well, this is what I was kind of asking, if you were seeing a return result was like a folio and like an offset, say, as a pair, as a paired struct, not as a page array, but as an offset where you could say, you know, I want the 100th page in the folio, and that kind of, instead of returning a struct page for the 100th page, you could return this compound type. Would that help? Is that something you imagine? And it kind of clarifies the reference counting that Kirill was asking about, because if you do get a folio, you know you have a ref count on the head page.
Yep.
And maybe that's the place to start pulling on this thread, is to change the places that get the ref counts to give you ref counted folios, and then work backwards from there.
Yeah, I mean, there's still the open question about what to do about page tables, right? Because they do have that old.
Well, it's the same. Like it's
yeah.
You pull out. You have to get the ref count on the head page when you take it out of the page table. So it always does boil down to a folio and an offset. That's what you ref counted at least. And there may be, you know, optimizations where it's ranges, not just a single offset. But
yeah.
That probably undermines your argument for less code, though.
May I state my prejudice on this?
Please.
It's really nice to see the name Folio coming back into use, but I think it's sort of tempting you. I think the delight in the name is pulling you down this path of going that way and changing all this, a whole lot of churn. And I myself don't really think that it's worth it. The sort of agreement that Kirill and I, the uneasy agreement that Kirill and I came to when he put in all the compound heads was, okay, some source module, some objects that get quite a bit bigger because of all those compound head calls. It appalled me at the time, and particularly I think swap.o, particularly when you have all the bug-ons, the sort of one after another, testing the different flags. It was horrific to me. But I think the kernel, I tried building the kernel with and without, and maybe it was 4K bigger with Kirill's changes in. I'm sorry, I'm making up that number, but it wasn't awful. And yeah, sort of I grudgingly let him do this backdoor stuff for compound head, feeling fairly sure that 0 day would start pointing its finger at all his changes because everything had got terribly slowed down. It was completely silent. There was no sign of any performance degradation at all. I was terribly disappointed. So I think you have to get a much stronger justification for all the churn. And the thing, although we like to, well, the kernel has always been something that is under construction, and people, it's the usual thing about living in a house while the builders are rebuilding it. But what with stable kernels and backporting to state a fix, someone has a fix, and to backport it to a stable kernel, I don't really like changing so many instances of the word page to the word folio. So I'm on the skeptical side.
You know, I think the stable, I totally I totally understand. I prefer to use the analogy of flying in a plane while the wings are being rebuilt and the engines are being upgraded. But yes, I think as far as stable goes, I think we can provide a compatibility layer, because it doesn't really change all that much. You can put in the infrastructure without having to convert everything all at once, because a struct folio pointer is a struct page pointer. And so if you end up passing a struct folio pointer to something which is expecting a struct page pointer, it's actually binary compatible.
Yeah, I think
go
you're
ahead.
a good job in on those lines, but the churn does not appeal to me.
I wanted to add a couple of things about this that I thought were really compelling before. Well, you know, in addition to Matthew's thing about the size and the CPU runtime pipeline mess ups that we have, but I kind of wrote down, I guess, a couple of things. One is during the gup.c work to add in the pin user pages stuff. And then during a couple of recent, like, you know, yesterday, code reviews of some changes that when you're fooling around in gup.c, it's just one tiny part of the kernel, but you're constantly dealing with either, is it a struct page or is it a compound head, you know, that's a struct page. And so it's a perfect microcosm of the complaints at the code level of what you're seeing on the screen, as opposed to, you know, what it turns into after you assemble it. And to me, the benefits are pretty nice. In fact, I almost look at it like it's almost like beneficial churn, because when I know that sounds messed up, but you know, you go into this set of functions and you're like, okay, you know, I got 5 functions and 3 of them call each other, and you know, they each call compound head because they might also be called from somewhere else that you don't know it's really compound head. And by the time you look at the explosion of, you know, fan in and fan out, you're not always totally sure, or you know, that today and tomorrow you're going to be safe for a random page coming in. Whereas if you can just lock down a few of those entrances with Page Folio or, you know, a type safe entrance, then all of a sudden you can collapse this stuff down. And we saw that immediately with some of these changes. And we also saw that in a couple of cases, we couldn't safely do it. So from a coding point of view, it just strikes me as a huge win.
Matt, why did you think it was 100,000 lines? I just did a quick look. There's only 98 calls to compound head in the directory. You think that expands to 100,000?
No, if we go for this fully, then every call to get page, every call to put page, every call to lock page, and every call to capital P page anything, or clear page anything, or set page anything. And I honestly pulled 100,000 off the top of my head.
Okay.
I don't know if it's that many, but it's almost every, it's definitely every file system. It's probably quite a lot of device drivers.
But I feel there's a middle ground here between everything that we could possibly do and some things.
Yes.
That, and Hugh's objection to the churn is good. But if we just did like the 98 call sites in for instance, and left a duality in other places, are we ahead? I think maybe yes. I think John is right. gup.c is dramatically ahead by using Folio, just in terms of understandability and maintainability. I don't know if other places would benefit similarly though.
But if you convert GUP, you have to convert all call sites of GUP, and it's
No.
drivers.
I just mean inside of GUP, just the part of GUP that's manipulating page references. GUP would still return the struct page array.
And then we can add an interface to let callers ask for folios instead of pages.
So yet another set of GUP-like functions, but for Folio.
So yeah, GUP has a problem, and I don't want to really use this call to talk about it, but I mean, the problem with GUP is it returns one thing and it spends 8,000 lines of code to do that. And we all want it to return 3 or 4 different kinds of things. And the GUP challenge is to how do you make that generic without destroying the performance?
So your point about not wanting to dive into that is well taken, but I think that is actually something we ought to discuss. So how about we dedicate this meeting to that? Our next one would actually be Christmas Day, so that's obviously not going to happen. But the well, yeah, I mean, I don't actually have anything better to do, but I think my wife would object. So we have a meeting on January 8th, and why don't we talk about GUP on January 8th? I think that would be a fascinating topic to dive into.
Yeah, I've learned a lot about it. I have some observations I'm happy to talk about randomly for a while. GUP certainly has been the nemesis of a lot of us in the I/O space because it's the only way to get access to memory for I/O. And these days, there's definitely classes of systems where the majority of the memory, like terabytes of memory, are being used for I/O, not the usual stuff you might use memory for, like page cache or things.
I definitely don't have any of those systems in my cloud. No, definitely not.
No, definitely. Yeah. My company doesn't sell any either. So.
Well, and the timing is good because there's a couple of decision points coming up. One of them is Christoph Hellwood keeps bringing up his old GUP BVEC patch where he slams in the union of BVECs in over the struct pages storage. Yeah. And the other one is how far to go with pin user pages. You know, the current plan is to continue on and convert the direct IO callers, thus blending in long-term and short-term users of DMA pin pages, or not. So both those things would be good topics.
Cool. Okay, so we can set the agenda on the mailing list. Let's get back to Page Folios for today.
So I think to justify for Hugh, could you find, like the page cast also sounded from your description, Matt, like it benefited greatly to have the type safety that everything in the page cast is actually a head page. And that's what we're enforcing. Having the compiler help do that sounds valuable to me, at least. GUP
Yeah,
is
no,
useful.
that's definitely my area of interest is file systems, because this is actually all Derek's fault.
Yay.
Yes, it's your fault we're improving the kernel. So I added THP support to deduplication, and Derek said, "What the hell is this THP head macro, and why does this not need a comment to explain what it does?" And I was like, you know, we've done a very poor job of explaining to file system people what transparent huge pages are and why they should care, and you know, when should they need to use them. And so I thought, okay, what we need is this new type, the folio, and then I realized all these other things that it could be used for and what advantages it had. The only disadvantage, of course, being the major churn to get us using it everywhere.
So, but if we were just to put the folio.h header in and do the churn for areas that clearly had improvement,
Yeah.
and sort of feathered this out over the usual kernel time frame of forever,
Yeah.
Does the churn for the stable kernels, you know, is that too much of a problem? You could push back on things that don't obviously have immediate benefit. Like, does that make you feel better, Hugh?
Not really, because particularly when you're doing a sort of a partial job like this, you then, every change that you make, you think, oh God, should I use pages here or should I use folios?
Well, I would say new code should use folios, right? New code should use folios. If you're writing and reviewing new code and it would benefit from folios, it should use it.
I'm certainly not convinced. And I would certainly like to see a performance demonstration.
Well,
before
Zhao's patch set, I think we're showing, I don't know, it was ridiculous. It was like 5
was
times
like
performance win or something silly.
even more than that.
Sorry, in what area was that?
This was in GUP. Like GUP gets a major performance win by aggregating its work onto a per folio basis.
So does that need folios?
No, but it's a lot easier to see
Okay.
and understand if you have some type for the head page. Right, this has been, like I said earlier, this has been an optimization waiting for someone to do for a long time now. And when you look at the code, it's not obvious that this is possible. You have to dive into every function that takes a struct page and understand that it immediately is working on the compound head, and that all of this work just boils down to atomic ink. Instead of 1, it's atomic ink with a number. And there's tons of it like this. And you can't see it.
In that case, GUP has regressed in recent years, because I'm pretty sure the last time Kirill had anything to do with it, it was definitely doing a single adjustment for
the THPs kind of threw a wrench into that, I think, because if you look at GUP of I don't know,
the THPs, it was doing a single. There was instead of doing a ref counting, there was an aggregated. It was building up a number.
That's present on one of the bajillion call sites inside the get side of GUP. It doesn't do every place that works with huge pages, and it doesn't do anything for the unpin side, the put pages side.
And I'm really not convinced that you need to go the folio route to make this optimization.
Oh, you absolutely don't. It's just clearer and easier to see. That's it.
It's riskier if you don't have the type safety. So sometimes the type safety translates into you can, if cost effectively, write code that's going to run faster.
I mean, the usual escape we have for not using for not having a type safety is to call the page, is to say struct page start head. I certainly feel more confident having the compiler enforce the fact that it's a head page than I do having every reviewer say, "Oh, this struct page is called head. I must make sure that we really treat it like," you know. It's
Well, and then they'll add an extra call to compound head in just to be sure.
Just to be sure.
That's how it works.
Yeah,
It is.
that is how it works, but hopefully those can be compiled out, except of course Fedora will enable the option that lets you compile it out.
I think for backporting, you could probably just define folio as struct page. And
The wonderful thing about the word folio is there are no current uses of the word folio anywhere in the Linux kernel. So you literally can do hash define folio page and it would work.
I was impressed that you came up with a word that was not used.
also
I managed
impressed.
to find 3 or 4, like a sheaf or I had 3 or 4. Ream, yes, ream. That's right. We don't use the word ream anywhere, which surprises me given the multiple uses of the word ream.
What is the general like community feeling on type safety in Linux? I never get a really solid read on this. I see in some areas people are like, yeah, type safety, we need type safety. In other areas it's like, it's okay.
I think you just described it.
I think it depends where it's business in the past, right? When you have unsigned long flags and you're like, what flags? Are these gut flags? Are these follow flags? Are these oh yeah, GFP flags or FGP flags or yeah.
Or not really flags, but they're numbers you have to shift up so they'll become flags.
Yeah, we've got a few of those. I mean, you know, Linus actually went to the trouble of writing sparse to do the, you know, he had the bitwise modifier on it, so he could do that. He could actually check that we were not doing stupid things.
Let's not forget the ever popular flags that aren't listed as flags, but you just have to know that they're flags by reading the code, like when addresses go odd.
F-allocate.
Yeah.
I mean,
Yeah, I didn't want to talk about page mapping today, Bill, but you know, you're going to make me bring it up. So this
seems
is
to apply.
Yeah, well, so it does. So I was looking at, okay, I'm trying to solve the problem. If we have a struct folio, what is the best way to get the index of that folio, like the index within a file? And the obvious answer to that is call a function called folio_index. But we already have a function called page index, which is not precisely the same as doing page arrow index, because if you have a swap page, then the index into its mapping is actually contained in some of the bits in page private, because page index is being used for something else.
And FishCLB also has exception.
Yeah, yeah, I wasn't going to get into that, but yes, you're right, it does. So what I was wondering is, we're adding a bit of type safety by having folios be just the head, or folio is a non-tail page. Do we want to go further? Do we want to have another type that says, I am a file folio, and therefore, if you call file folio index, passing it to struct file folio, then that really is just dereferencing the index. But we already have a lot of...
Or we should just make index means the right thing for all type of pages.
Yes, I asked Bill to look at that a while back. Actually, Liam, you know about this. You know about how page index is used in VMAs, right? In anonymous VMAs.
A little.
Don't you? I remember we were looking at this a while back.
What's the question?
So, correct me if I'm wrong, because I often am. the way we use for anonymous pages, the way that we use page index today is that it is the offset in pages from the beginning of the VMA.
Oh, the offset, the VMA offset doesn't mean what it means yet in the anonymous VMA. I don't actually think we use it in anonymous VMA,
Okay.
or maybe,
I think,
We use it for Irma.
yeah.
It's, I believe it's required to look up in the unknown VMA reverse map tree to get like all LinkedIn VMAs and all this stuff.
And most
yeah, it is
important-
set for that, you're right.
And it came into existence because of Emery map move. Because if you have an area and you Emery map move it somewhere else, you need still to be able to find the anonymous pages. They need still to connect up with the different mappings of those same anonymous pages, even though the thing has been moved. And even if parts have been split off and so forth. And that is why the index is important. You can't just deduce it from the start of the VMA.
Hugh, isn't there also a problem if we swap the role of page private and page index? Isn't there also a problem with Shemem pages when they get swapped because you have to change their their page index?
There probably would be, but I mean, the fact that page index never changes after the page has been assigned to cache is something that we could give up on. That's not a deeply. I think truncate.c is about the only place, or on the equivalent part of shemem.c, the only places that desperately rely on that, possibly a few bug-ons somewhere. But that's something that could be given up on. But I don't see a need. I think there are places in the code, they may only be very short intermissions, but places where you need both at the same time in the same struct page. Because there isn't a way of atomically flipping them. What I've always objected to much more strongly is the fact that page mapping takes on values for swaps. I think I used to have arguments with Andrea about this. I was very. It's all. I put in the comment about it being a fiction. The whole thing about the mapping address space is it's just a sort of trick in order really for the right page method to sort of magically bring you to swap, so that whereas all over the place nowadays we have sort of checks on swap backed and swap go this way and shemem go that way and blah, blah, blah. In those days it was all tried to go through the file operations, and by tricking us into having swap managed by something that looked like an address space that had no inode, it sort of passed magically that way. But it's all a fiction.
That's a very polite way to put it, Hugh. I've actually been wondering about whether swap needs to be rewritten to just do direct IO, because it's now very, very easy to do direct IO within the kernel.
You're not talking about getting rid of the swap mechanism itself.
Well, maybe.
Well, I mean, 'cause that's where the device memory is hiding right now for the HMM game. It looks like a swap device. So it's swapped out to device.
Right. Yeah, I would have to think about that. No, I mean, this is not a project I'm realistically going to embark on anytime in the next 2 years. I have enough real work on my plate to probably doing this.
We'll try to get everyone to build memory coherent hardware in the meantime before you get there.
Oh yes, CXL is coming, or indeed already here on some platforms. Yes. Oh, we're almost at the top of the hour, so we've got 3 minutes left. Anything anyone else wants to talk about before we wrap up?
Derek here. I kind of like the idea of having built-in type safety for idiots like me who, at his current rate of progress, might understand how the memory manager works at around 2028, just in time for all of you to have completely changed it again. So it makes it very easy to review file system code if, when we need a struct file folio or whatever the function we're calling just says, I need one of these, versus a struct page, because we're actually fiddling around with individual pages. But that's mostly a vote for, you should do type safety to protect yourselves against idiots like me argument.
I was thinking we should do type safety in order to protect you against idiots like us, but you know, sure. Yeah, I mean, a lot of this does come from having worked on IOMAP extensively as part of the THP work, and I just strew the IOMAP code with VM bug on PG flags if page tail. And then I started and that was great, because I was absolutely certain that I wasn't dealing with tail pages anywhere. And then I realized that IOMAP was in fact not the only file system that was going to need to be converted, that we're going to have to do a dozen others. And did I really want to tell people who are working on other file systems, oh yeah, you need to go and put all these VM bug on PG flags just in case anybody in the MM layer decides to change how these things work? And I felt a little bit sick, and so I thought, yeah, we really need to type. We need to type for this.
I protest against your discovery of VM bug on PG flags. I had never heard of it until you inserted one somewhere, and I what the hell is this? And I searched free, and it's something some deeply embedded internal from Kirill.
I'm very sorry about that. It's really, really ugly, and I hope that Folio can help with getting rid of it.
To get rid of PG flags?
No, getting rid from this indirection in PG flags, when you had to, like, when I tried to hide the fact that we reference head pages in most cases. And yeah, it's ugly, and it's
I wasn't. In fact, I don't think I got to the bottom of what was referencing what. But as far as I'm concerned, VM bug on PG flags is a low-level internal thing, and VM bug on page is what everyone is using. I just hate these places where someone comes up with another name for almost the same thing as you started off with, and you spend the next hour or two debating with yourself, oh God, should I write it with this one, or should I write it with that one? VM bug on page is what is being used everywhere. And I was a bit worried to see some obscure alternative creeping into the code.
Well, thank you for bringing that up, because I didn't realize I was doing anything wrong. I thought I was following the existing practice. So I will happily go and take out all the VM bug on PG flags that I have added as part of my patches, or that turn them into VM bug on page. Yeah, I just thought, okay, that's a deeper level of debugging needed. Okay.
Kirill's the one who understands the difference between them. he may have a different opinion. But to me, it was a shock.
It was meant only to be used inside page flag helpers, and that's all. And shouldn't be visible outside. So yeah.
Okay. Thank you. All right. I'll stop the recording here, and thank you all for coming. I really appreciate this. A lot of you have spoken. I assume you generally feel that this was useful. I'm seeing nodding. Yeah.
Yes.
Okay. So
It's a fun difference from just looking at patches on the mailing list.
isn't it though? Yeah. Okay. So January 8th, we'll discuss GUP.
You'll send something, Matt?
Yeah. Yeah. Sure. I'll send something out. Okay. Great. Thank you all for coming, and talk to you in 4 weeks.
Have a happy holidays, everyone.
Yes. Happy holidays. Thank you.
Bye bye.
Take care.